Good day, no? So for today, we're going to discuss first about the software processes, no? So last time, I will give you a background or an introductions of the entire topic that we're going to cover with software engineering. So the software processes, no? Software development process models overview, no? So software development processes are structured approaches that guide the planning, no? Criterion, testing, and maintenance of software, no? Different models offer distinct advantages depending on project goals, no? Complexity, and the desire, no? Flexibility or predictability. The major models include, syempre, yung common, yung waterfall. Actually, pag nakikita ko sa student, provided na ang waterfall model nila is revised, no, or improve, okay lang naman po. For as much as possible, we are always advise our students to try to look with agile, no, spiral, and others, which emphasizing unique methodologies and workflows, no. So kung kayo po ay professor right now, or kayo po ay nasa private or industry, better for us to use to look for an agile process model. Ano po? Because again, waterfall model is a linear and sequential approach that treats software development as a series of stages. And these stages, number one, of course, yung common natin, no, requirements gathering, we have design, we have implementation, testing, deployment, and maintenance. This will be completed in strict sequence dapat. No? So only once a stage is completed, does the process move to the next. So meaning no overlap between stages. And this model is best suited, no, for projects with clearly defined requirements, as many changes can necessitate revisiting prior stages, which may be, syempre, costly yun, ano po. And syempre sa development natin, hindi natin na-advise yung medyo magastos. Hanggat maaari, we look forward doon sa makakatipid tayo. Okay. So I just want to play a two video presentation, no? Focus on this discussion. Okay. Looking forward na mag-play ang video ko. No?
At this point, you know the possible activities, the possible phases performed during the software development process. But there is something that we still haven't discussed, which is very important. And that is, how should we put these activities together to develop software? And this all comes down to the concept of software process model, also called software lifecycle model. And what this is a prescriptive model of what should happen from the very beginning to the very end of a software development process. The main function of a lifecycle model is to determine the order of the different activities so that we know which activities should come first and which ones should follow. Another important function of the lifecycle model is to determine the transition criteria between activities. So when we can go from one phase to the subsequent one. In other words, what the model should describe is what shall we do next and how long shall we continue to do it for each activity in the model. Now let's see a few traditional software process models. I will discuss them here at the high level and then revisit some of these models in the different mini courses. The first model I want to discuss is the grandfather of all lifecycle models, and is the waterfall model. In the waterfall model, a project progresses to an orderly sequence of steps, from the initial software concept down until the final phase, which is system testing. And at the end of each phase, there will be a review to determine whether the project is ready to advance to the next phase. The pure waterfall model performs well for software products in which there is a stable product definition. The domain is well known and the technologies involved are well understood. In these kind of domains, the waterfall model helps you to find errors in the early local stages of a project. If you remember what we discussed, this is the place where we want to find errors, not down here, because finding them here will reduce the cost of our overall software development. The main advantage of the waterfall model is that it allows you to find errors early. However, the main disadvantages of the waterfall model arise from the fact that it is not flexible. Normally, it is difficult to fully specify requirements at the beginning of a project, and this lack of flexibility is far from ideal when dealing with projects in which requirements change, the developers are not domain experts, or the technology used are new and evolving. That is, it is less than ideal for most real-world projects.
Okay. So again, this will be the old one, no, as what our videos mentioned, that this will be the grandfather of all process model. The agile model is flexible, no? Iterative approach that breaks down the development process, no, into small manageable units called sprints, no. It's typically lasting 2 to 4 weeks, no. So agile emphasizes customer collaboration this time, no. So welcoming changes even late in development. So teamwork in cycles, no, incorporating feedback, continuously making agile ideal for projects now where requirements are expected to evolve. So agile's adaptability, however, requires discipline management to prevent score creep. Ano po pag agile naman?
That I want to discuss are agile software development processes. And this is a group of software development methods that are based on highly iterative and incremental development. And in particular, I'm going to discuss test-driven development, or TDD. It's based on the iteration of 3 main phases. In the first one, that we mark as red, we write test cases that encode our requirements and for which we haven't written code yet, and therefore they will fail, obviously. So we're in this sort of red or fail phase. From this phase, we move to this phase in which, after we write just enough code to make the test cases pass, we have a set of test cases that are all passing, and therefore we can consider this as the green phase. We have enough code to make the test cases pass. Because the test cases encode our requirements, we have just written enough code to satisfy our requirements. When we do this over time, though, what happens is that the structure of the code deteriorates because we keep adding pieces. So that's why we have the first step, which is refactoring. In this step, we modify the code, and we will talk about refactoring extensively. We'll devote one lesson to it. We modify the code to make it more readable, more maintainable. In general, we modify it to improve the design of the code. And after this phase, we will go back to writing more test cases for new requirements, write code that makes these test cases pass, and so on. So we'll continue to iterate among these phases. And also in this case, we will talk about agile software processes, and in particular about extreme programming, or XP, and Scrum in more details in mini course number 4.
Okay, so another one is the spiral model, no? The spiral model, no, combines iterative naman and linear development approaches, making it particularly suited, no, for complex and high-risk projects. No, each phase, no, planning, risk analysis, engineering, and evaluation is completed in a spiral loop, no, with each loop, no, representing an improved version of the product. So this model, no, allows for incremental improvements, no, while focusing on risk assessment, making it valuable for critical projects, no, where risk must be carefully managed. However, a spiral can be complex and resource intensive. Ano po?
Is the spiral model, which was first described by Barry Beam, which is the professor that we interviewed at the beginning of this lesson, in his paper from 1986 that was entitled A Spiral Model of Software Development and Enhancement. And one of the main characteristics of that paper is that it was describing the spiral model using a diagram, which is the one that I'm showing you here. And this diagram has become very, very popular. And you probably saw it either in this form or one of the many variations of the diagram. So I'm not going to discuss all of the details of the spiral model, but I just want to give you an idea of its main characteristics. The spiral model is an incremental, risk-oriented life cycle model that has 4 main phases listed here: determine objectives, identify and resolve risks, development and tests, and plan the next iteration. A software project will go through these 4 phases in an iterative way. In the first phase, the requirements will be gathered. In the second phase, the risks and the alternate solutions will be identified and a prototype will be produced. Software and tests for the software are produced in the development and test phase, which is the third step of the process. Finally, in the fourth phase, the output of the project so far is evaluated and the next iteration is planned. So basically, what the spiral process prescribes is a way of developing software by going through these phases in an iterative way, in which we learn more and more of the software, we identify more and more and account for more and more risks, and we go more and more towards our final solution, our final release. There are several advantages of using a spiral model. The first one is that the extensive risk analysis does reduce the chances of the project to fail. So there is a risk reduction advantage. The second advantage is that functionality can be added at a later phase because of the iterative nature of the process. And finally, software is produced early in the software life cycle. So at any iteration, we have something to show for our development. We don't wait until the end before producing something. And that, of course, has also the advantage that we can get early feedback from the customer about what we produce. The main disadvantages, on the other hand, of the spiral model are that the risk analysis requires a highly specific expertise. And unfortunately, the whole success of the process is highly dependent on risk analysis. So risk analysis has to be done right. And finally, the spiral model is way more complex than other models, like, for example, the waterfall model. And therefore, it can be costly to implement.
Okay, so of course, we have another what we call V model. No? Yun po yung verification and validation. So the V model is an extension of waterfall. No? That's why, as I mentioned earlier, better for us to acknowledge the waterfall with modification. No? And one of those is the V model. So the V model is an extension, as I mentioned, of a waterfall, emphasizing validation and verification at each development stage. So each development stage has a corresponding testing phase, no? Ensuring that the product is verified and validated thoroughly. So it's ideally for projects requiring rigorous testing and high quality, such as medical or yung automotive software, because the B model's rigid structure makes it challenging to adapt these changes. No? And another thing, of course, I just want to share again.
Next process model I want to discuss is evolutionary prototyping, which works in 4 main phases. We start from an initial concept, then we design and implement a prototype based on this initial concept. We refine the prototype until it is acceptable, and finally we complete and release the prototype. Therefore, when developing a system using evolutionary prototyping, the system is continually refined and rebuilt. So it is an ideal process when not all requirements are well understood, which is a very common situation. So looking at this in a little more details, what happens is that developers start by developing the parts of the system that they understand, instead of working on developing a whole system, including parts that might not be very clear at that stage. The partial system is then shown to the customer, and the customer feedback is used to drive the next iteration, in which either changes are made to the current features or new features are added. So either the current prototype is improved or the prototype is extended. And finally, when the customer agrees that the prototype is good enough, the developers will complete the remaining work on the system and release the prototype as the final product. So let's discuss, as we did for the previous process models, what are the main advantages and disadvantages of evolutionary prototyping. In this case, the main advantage is the immediate feedback. Developers get feedback immediately as soon as they produce a prototype and they show it to the customer. And therefore, the risk of implementing the wrong system is minimized. The main negative is the fact that it's difficult to plan. When using evolutionary prototype, it is difficult to plan in advance how long the development is going to take because we don't know how many iterations will be needed. And another drawback is that it can easily become an excuse to do kind of code and fix kind of approaches in which we hack something together, fix the main issues when the customer gives us feedback, and then continue this way until the final product is something that is kind of working, but is not really a product of high quality. Something else I want to point out before we move to the next software process model is that there are many different kinds of prototyping. So evolutionary prototyping is just one of them. For example, throwaway prototyping is another kind of prototyping in which the prototype is just used to gather requirements, but is thrown away at the end of the requirements gathering instead of being evolved as it happens here. There are two more software process models that I want to cover, so bear with me. The first one is the Rational Unified Software Process, or RUP, which is a very popular one based on UML. RUP works in an iterative way, which means that it performs different iterations, and at each iteration, it performs 4 phases. So what I'm showing you here is a high-level view of the process, and I don't want you to focus on all the different details, because we will discuss these details later on in a lesson that is actually dedicated to RUP. What I want to give you now is just the gist of how this works. So in each one of these 4 phases, which I'm going to describe in a second, we perform standard software engineering activities, the ones that we just discussed, and we do them to different extent based on the phase in which we are. In particular, in the inception phase, the work is mostly to scope the system. So basically figuring out what is the scope of the work, what is the scope of the project, what is the domain, so that we can be able to perform initial cost and budget estimates. The elaboration phase is the phase in which we focus on the domain analysis and define the basic architecture for the system. So this is a phase in which analysis and design are particularly relevant. Then there is the construction phase, which is where the bulk of the development actually occurs. And as you can see here is where most of the implementation happens. And finally, the transition phase is the phase in which the system goes from development into production so that it becomes available to users. And of course, this is the phase in which the other activities in software development become less relevant and deployment becomes the main one.
Okay. So an incremental models combines elements of linear and iterative development, creating software in increments. Each increment is a partial product with basic functionality in the first iteration and additional features in subsequent iteration. So this model actually is very beneficial when the core requirements are known but details may evolve. Incremental development allows for delivering a functional product early, but it requires careful management to integrate each new increment seamlessly. We have what we call software process improvement. Now, software process improvement, or SPI, is the practice of analyzing and enhancing software development processes to improve efficiency, quality, and outcomes. So software process improvement, methodologies like yung very common, yung CMMI, the capability, maturity, the capability maturity model integration, at syempre yung mga ISO, ISC standards. Now, provide frameworks, most commonly used pala sa ISO yung 9126, So it provides frameworks for assessing and advancing software processes, reducing defects, and improving delivery timelines. Software process improvement is important for long-term project success and organizational growth, fostering continuous improvement and competitive advantage. Now, comparing waterfall and agile, because if we suggest to our students, especially taking advanced software engineering or kaya naman system design 1 and 2, they were asking, sir, you are always advise us to use agile rather than waterfall model. So it is important for us to compare or to discuss with them how to differentiate waterfall to agile? Waterfall and agile represent opposite ends of the flexibility spectrums. Why? Waterfalls, linearity, and predictability are valuable for projects with stable requirements, but can be restrictive for projects that evolve over time. Wait. So, Agile's adaptability, no, in contrast, support projects with dynamic requirements, no, enabling the team or teams to respond to change quickly. Agile's customer focus kasi and iterative nature aligns well with user-driven industries, while waterfall model remains popular in fields with stringent regulation and minimal room for modification like defense and aerospace. So again, may pinagbabagayan ng paggamit ng agile at ng waterfall model. Again, agile must be a customer focus and iterative natures. Waterfall model remains in the field with stringent regulation and minimal room modifications. How about agile in spiral? Both agile and spiral incorporate iterative cycles but differ in focus. Ano pong ibig nyo sabihin, Doc? Agile emphasizes customer satisfaction and adaptability with regular feedback and fast cycle. Spiral, on the other hand, focuses heavily on risk assessment, making it ideal for projects where failure could have significant consequences, such as yung mga government healthcare projects. Ano po? Agile, shorter cycle promotes agility from the agile itself term, no? While spiral in-depth analysis at its iteration is better suited for complex, high-risk endeavors. How about process improvement in waterfall versus agile? Kasi kanina sabi natin pa rin mga B model. In waterfall, process improvement often happens take note ha, post-project through retrospectives and lesson learned, making adjustments in subsequent projects. So in agile naman po, improvement occur continuously with each sprint, offering an opportunity for reflection and adoption. Agile teams use tools like retrospectives and process reviews, allowing them to quickly incorporate lessons learned, unlike waterfall where changes may only be visible in the next project cycle. So what will be the role of process improvement in software development? Process improvement drives software development efficiency and quality. Now, particularly in competitive markets where customer satisfaction and rapid delivery are essential. Continuous process improvement, as seen in Agile, enables teams to streamline operation, reduce waste, and refine practices, ultimately improving productivity and product quality. Process improvement initiative help address bottlenecks, minimize defects, and align with business goal. How about the risk management in the spiral, as what we have mentioned earlier? The spiral models focus on risk management, as what we discussed earlier, is a unique among process models, because risk management and mitigation are prioritized, reducing uncertainties before progressing to subsequent stages. And this approach is particularly valuable for large-scale or critical projects where the cost of failure is high. Siyempre, kung malaki ang project, malaki yung budget, ano po? So better for us to adopt the spiral model. Okay. Risk assessment kasi helps identify potential issues early, enabling proactive measures, which is less emphasized in models like Agile or Waterfall. How about the customer collaboration in Agile? Kasi 'di ba, sabi mo kanina, Doc, ang Agile is with customer collaboration. Agile success is largely attributed to its emphasis in customer collaboration with customer feedback integrated into every sprint. This interaction help teams remain aligned with evolving customer needs, ensuring a product that better satisfies users. So continuous feedbacks from agile teams to adapt quickly to market shifts, making agile ideal for sectors with dynamic customer requirements. Dapat nangyayari to, especially kung ang project ng inyong students or kayo personally ang gumagawa ng customized project, kung let's say ang inyong project ay intended for San Miguel Corporation, specifically for finance department, better for you to have a person from that department who could able to join with the group during the yung development, di ba? Para, di ba, sabi nga natin kanina, because the customer feedback or continuous feedbacks allows agile teams to adapt quickly to market shifts, making agile ideas for sectors with dynamic customer requirements. Agile and RAD is parang claiming about flexibility and adaptability. Both RAD and Agile offer flexibility through syempre in different way, because RAD focuses on or rapid application development yung RAD. RAD focuses on rapid prototyping and high customer involvement, allowing for quick changes during development. Agile sprints-based approach also support adaptability but with a structured workflow. RAD is suitable for project required fast turnaround, while Agile is ideal for projects where requirements are expected to change. We have also heard the iterative and incremental in Agile models, right? Iterative development and incremental and agile models. Incremental and agile models both employ iterative development, right? With features added progressively. However, in the incremental model, each iteration produces a working version of the software, while agile delivers small functional parts with each sprint, refining the product over time. Incremental approach is suitable when foundational aspects are fixed, when Agile is designed to evolve the product dynamically. Now, how about a continuous improvement in lean principles in Agile? Agile actually aligns well with lean principles, emphasizing value creation, waste elimination, and continuous improvement. So Agile teams adopt practices like retrospectives, sprint reviews, and process adjustment to foster continuous improvement, helping teams eliminate inefficiencies and enhance productivity. So lean principles help Agile teams focus on delivering high-value features, optimizing the development process. Now, I just want to share the last video presentation.
And there are many, many more. And because these process models define the master plan for our project, the specific process model that we choose has as much influence over a project's success as any other major planning decision that we make. Therefore, it is very important that we pick the appropriate model for our development process. Picking an appropriate model can ensure the success of a project. On the contrary, if we choose the wrong model, that can be a constant source of problems, and ultimately, it can make the project fail. So how can we choose the right model for a project? To be able to do so, we have to take into consideration many factors. In particular, we need to be aware of what level of understanding we have of the requirements. Do we understand all the requirements? Are we going to be able to collect all the requirements in advance? Or collecting requirements is going to be hard, and therefore we might want to follow a process that is more flexible with that respect. Another important point is the expected lifetime of the project. Is this a quick project that we're putting together for a specific purpose, or something that is going to last for a number of years and that we're going to maintain over all those years? That's going to make a difference in the way we decide to develop that project. Also, what is the level of risk involved? Do we know the domain very well? Do we know exactly the technologies involved? Well, if so, we might go with a more traditional process. Otherwise, we might want to be more agile, more flexible. It is also very important to know the schedule constraints. How much time, how many resources do we have for this project? What is the expected interaction with the management and the customer? In particular for this latter, there are many processes that rely on the fact that there can be a continuous interaction with the customer. If that interaction is not there, there's no way we are going to be able to use these processes. Conversely, there are processes that don't require the presence of the customer at all, except for the initial phase and maybe some checking points. And so if the customer is very inaccessible, we might want to follow one of those processes instead of one of the more demanding ones in terms of customer time. Finally, it is important to take into account the level of expertise of the people involved. Do we have people that know the technologies that we're using? Do we know people that know a specific kind of process? Some processes require some specific expertise, and we're not going to be able to follow that process if we don't have the right expertise. So we need to take into account all of these aspects and sometimes more in order to be able to make the right decision and pick the right software process model for our project. So now that we know what
Okay. So, to sum up, no, the discussion about software processes, no, understanding and selecting the right software development process model is critical to project success. That's why, as professor, no, if you are handling especially the undergraduate program, better for us to give them all those pros and cons, no, of different software models or software development models, no, because each model, no, offers a unique benefits and challenges, from the predictability of waterfall to the flexibility of agile and the risk focus of spiral. So process improvement initiative, whether through agiles man yan, through agiles iterative feedback loops or waterfall post-project reviews, it plays an important role in refining workflow, improving product quality, no, and aligning with the business goals. So the right combination of process model and improvement strategy allows organizations to deliver the high quality software that meets user expectation efficiently and effectively. So I think that's it for this topic.